world, we are all in the middle of a quantum race. Countries like China, USA, UK, Japan, and India are also investing millions and billions of dollars, pounds, and yens into developing quantum computing technology for decades now. This is because quantum computing is as heavy duty as it sounds. This technology holds the power to solve the toughest problems in the world, ranging from DNA analysis for gene abnormalities to encryption and cybersecurity. This potential is tremendous for the future progress of technology. Hello, listeners. Welcome to another podcast session. Today, we are discussing the impact of quantum computing in the tech world and how edge computing is leveraging its capabilities. Joining us is Prashanth Kaddi, who is a partner with Deloitte India. Hi, Prashanth. Welcome to the podcast.
Hi, Purva. Thanks for having me.
So let's start this podcast on a great note with you giving us a brief about your role and the area of expertise in Deloitte.
Sure. So my name is Prashanth Kaddi. I am a partner in what we call the data and AI practice, as we call it. Specifically, I focus on the AI competency, which I lead in Deloitte India. And we work together as part of a global AI competency across the world. So that's basically what I do for a living, dealing with a large number of data scientists and a few initiatives in AI that we have kicked off, which I will enumerate as we discuss further.
So as one of the tech giants, how is Deloitte contributing to the quantum and edge computing industry? Absolutely.
So from a quantum and edge computing perspective, I mean, just to set the background. So for as you rightly pointed out, it is heavy duty. Let's take quantum computing and can take, for big problems such as, let's say, forecasting weather, as well as, let's say, self-driving cars, as we call it, right? Autonomous cars. So these are some of the problems that widely have been used. But fundamentally, in the business scenario, there are 3 or 4 types of problems that quantum computing can play an important role. One is simulation, especially in industries which our clients are, where there is significant amount of simulation that is required, right? For example, healthcare, for example, chemicals, and so on. The second is optimization, which could be both from a supply chain perspective, from a finance perspective, from manufacturing perspective, etc. And the third is search, right? Which is how do we look for meaningful information in large databases, large data sets, especially those which have sparse information. So, and again, I'll sort of talk about some of these things. So as Deloitte, we have set up globally what we call an AI Institute, which is looking at how we can do cutting edge work, both in concert with academia as well as startup ecosystems, right? As part of this, we have also, and I think it's a matter of public knowledge, that we have launched what we call the Deloitte Center for AI Computing, right? Where we are looking at, also an ecosystem where we're looking at some supercomputing capabilities, etc. So we are, through these efforts, we are trying to coalesce how we can be on the cutting edge of innovation. And we have some graduates from leading science universities in the US who are actually inventing applications which we can use quantum and edge computing for, right? And we're also collaborating with a lot of edge computing players in the market.
So keeping Deloitte's AI, institute in mind, as you said, according to you, how are disruptive technologies, other than AI, like big data and cloud computing, impacting today's innovation? And from that perspective, how has the role of the leader for AI and ML has changed over the years?
Fantastic question. So I think the advent of cloud and the whole host of technologies have, in a sense, democratized AI. AI is not something necessarily going forward that rocket scientists sitting in a lab have to develop. It is mainstream. It is for business applications, which can be fairly easily built. Also, with the computing power, with the inbuilt algorithms, so most of the cloud players, for instance, have included thousands of algorithms which are available for use rather than sit and write these algorithms, right? So therefore, the ability to quickly scale up, create solutions, and the ability to make it completely elastic, right? Which, I mean, I could go from building a model which does one thing on, let's say, a data set of 100,000 to 100 million without necessarily changing the basics of how it has been done, right? Because of the elastic nature inherent in the cloud. Having said that, what the leader's role has changed from is to be more, earlier it used to be the old, warfare where you have large armies of data scientists and developers who will get this done, maintain it, run it, etc. Increasingly, the single most critical skill that data AI ML leaders, including their teams, will need to have is to be able to translate quickly business problems into the right AI solutions, analytics, problem statements that are required, solve them quickly because there are a lot of low code, no code innovative platforms where it can be done quite easily, and translate it back to business and give it back in a meaningful way that adds value to business, right? So the last point perhaps I would say is also the interface, right? So for example, converting voice to text, text to voice, etc., has become so simple using, again, APIs which are available, that it is potentially possible to give customers a very rich experience of how they interact with AI systems and not necessarily, get into the mathematics of it.
So, as you said, Prashanth, that AI is not something rocket scientists are making. In the sense, the concept is not as complicated as people or non-tech people are making it seem, because there are several resources available that are now simplifying the process of making an AI algorithm or making a certain code. So, from that perspective, what is your view on the current scenario of quantum and edge computing industry? And is it similar to what your views on, AI and other disruptive technologies are? That it's not as complicated as people are making it seem.
So, at this point in time, there is a little bit, the rocket sciencey nature of quantum and edge computing is still there. Edge computing perhaps is a little more mainstream, I would say, and maybe if I just divide that, maybe I'll take edge computing first because that's a little easier. For example, some of the colleagues in our AI, the innovation teams are looking at, let's say there's a problem statement. I need to look at an image or a phone or a document, and in 15 milliseconds, I have to make a decision on it, right? So there isn't time for me to send it to a cloud or to a data center, run an algorithm and get a decision back. It has the computing and the algorithm has to run right there. And it could actually be housed inside a specs or spectacles or goggles that somebody is wearing, right? So those are the kind of use cases that are getting solved now using edge computing. And edge computing is quite straightforward or relatively because, our mobile phones, for instance, have more powerful, computing power than most of our laptops used to have, let's say 5 years ago or 8 years ago, right? So significant advance there. Also, for example, a lot of industries which have wide reach, let us say retail showrooms, let us say telecom tower companies which have towers are figuring out how to put edge computing facilities in those local areas so that the computing power is enabled as quickly, right? So phenomenally, I think that is moving quite fast, right? I mean, let's say even in a showroom, there's a video surveillance through video imaging analytics that has to be done quickly. We can't wait for the internet connection to upload that video. Somebody runs it and then comes back, right? So for instance, with a potential breach that happened. So edge computing, I would say, is the lot of here and now use cases which are already getting deployed. We see a lot of companies, and also a lot of, for example, cloud providers which are trying to push that as a means to give a cloud experience inside a premises of either a company or in a local area, right? On quantum computing, it tends to be a little more complicated because there are two parts to it. One is the quantum computers themselves, which obviously, allow us to do a little, nonlinear computation in an easier fashion than traditional computers. But also there are the quantum algorithms which are required, which means, let's say if I have to, devise a route optimization, or I have to do 100,000 simulations for saying what is the best options which are available, or if I have to look at, say, what will be the production of rice in the country based on some rainfall patterns, which are based on, let's say, weather patterns, and I have to predict all of these in multiple, multi-echelon kind of predictions, then running these algorithms actually on quantum computing. So the algorithm is as critical a part to enable the crunching, the millions of operations, as much as the quantum computers themselves. Therefore, that's a little bit more complicated at this point in time. It's not, it's not an API that we can read off and do at this point in time. But I mean, we believe that over a period of time, it will evolve, and this will also get democratized. But that might take a couple of years, if not a few years.
So you've mentioned a few applications of, quantum computing, and also said that edge computing is kind of commercial compared to quantum computing. So can you elaborate on how Deloitte is using these technologies and what solutions or what innovations it's carrying about?
Let me, sort of give you a perspective of the work that we are doing across, industries, and how we are doing what we do, right? So essentially, for instance, we spoke about some of the applications of edge computing. So let me talk about the simple example that I mentioned about, for example, let's say recognition of images. So let's say I want to do facial recognition of person who's walking into my showroom, let's say, for argument's sake, and give them a personalized experience based on what they like, and therefore try to position those items or articles which are more they are more amenable to see, right?
Right.
Let's say, so that I can't wait, for that to take a minute or two, and then, that becomes a bad experience. Similarly, let's say I'm applying for a loan, it takes 1 hour, 2 days, etc. So if I can give it in 1 second, actually that algorithm to run and actually approve it, that's the next level of customer experience, which can create the competitive advantage for clients, right? And they are doing it. Similarly, for example, autonomous cars is a classic case, right? I mean, if I have to analyze the video of what's going on around in a car which is driving by itself, I really cannot wait for all those inputs that I'm receiving, whether they're sensors or whether they're images, into a cloud, and then wait for a response, right? I mean, especially if the connectivity is not, let's say, great in some stretch of a highway or something, right? That it can absolutely have quite disastrous consequences. Similarly, across, I mean, even from if I go back and look at quantum computing, we are so increasingly, for example, supply chain in post-pandemic, there are significant issues which have been flagged off, and supply chains have typically kept only the optimization in mind, which is how do I sort of be more optimized, have not really looked at a resilience perspective, right? Saying how do I make sure that that there are no disruptions, right? So if you want to combine these, it's actually quite a complicated, because a lot of the data seems to be semi-structured, etc., unstructured. And how do you make sense out of it and come up with some decision support? Similarly, in encryption, for example, right, and cybersecurity, which has become very critical post-pandemic. So there are applications that where quantum computing is being actively used, and also, for example, like again more relevant in the post pandemic era where we have medication, drugs, etc. The simulations which need to go into before they can be sort of commercialized, or even look at a long term. A molecule needs to have a 10 to 20-year life, right? So how do we look at that um, uh, post discovery? So quantum computing applications have become quite significant there as well.
So for Deloitte to, leverage all these, all the quantum computing capabilities, like all of it that you mentioned, were there any major challenges that the company was facing? And also, did the pandemic add to those challenges, make it more severe? And how, did Deloitte face those challenges and overcome all those barriers?
So if we look at, I mean, across the industry, these are super hot skills, right? I mean, one of the secular trends we see post-pandemic is the exceptionally high demand for digitization and intelligence through AI and digital interventions, right? So because obviously physical interactions and several things we could do earlier are no longer possible, right? So so there are typically two or three challenges always, right? So one, talent is always a challenge. I would say that so for some of these which are cutting edge, we need absolutely top talent from the top universities globally and in India. So I think and maybe pandemic is not just one point. So I mean, I think up to, let's say, last year, I think there was not as much of a war for talent as there is right now. So I think, I mean, maybe 2021, the war for talent has got a lot more intense, right? So that's always a problem. Second, you do need some base investments, right, to get started off on some of these, right? As every enterprise would. So I think that level of belief and confidence in the technologies and their transformative nature, and obviously buy-in across and sponsorship across the leadership is very critical. And third, I would say is the ecosystems, right? So, for example, to have edge computing capabilities across multiple, let's say, locations, regions, etc. You do need to have the right platform. There are a lot of startups as well which are doing significant and interesting work across many of these topics, both in quantum and edge computing. And companies today which have big problems to solve, let's say, finance, insurance, or manufacturing, or logistics, etc. More than specific point solutions, they do need an orchestration of solutions, as I would say, which clearly gives return on investment to the business as well. So that's where I think, across the industry, we find some of the challenges that have been faced, and these are the sort of ways that they have been overcome. Which is, obviously, talent is always an ongoing challenge. So we need to have a career path and a plan, as well as the requisite investments to do the right, pace of innovation. The second, obviously, having the right sponsorship, making it clear, and also demystifying it, as you pointed out, to also the leaderships within the organization. And across enterprises. And thirdly, having the right tie-ups and partnerships, ecosystems in place, so that we're able to get this going. And last but not least, also it's very critical that as the saying goes, right, to a child with a hammer in the hand, the whole world looks like a nail, right? I think we should not take that approach as well. We should look at what the problem statement is and apply the right tool for the right job, right? Not everything may need an AI solution itself, for instance, right? I mean, there might be smarter, better, more efficacy, higher efficacy ways to solve the problem, higher efficiency as well, than to blindly, sort of put it. So similarly for quantum and edge computing usage. So I think we have to be selective in terms of where we apply what tool and which is, sort of the most appropriate.
I absolutely agree with you when you said, the right tool for the right task is important. And I feel that is what, makes technology into a boon rather than a bane, because you know what to do in order to make sure that, nothing destructive is happening, or nothing, there are no adverse effects to what you're trying to do. And you also mentioned that there are startups that are leveraging quantum and edge computing technology. And in India and even around the globe, there are, startups and, new companies that are innovating, quantum computing and trying to create solutions for, the tech world and its users and, clients. So, as a partner for Deloitte, I'm sure you overlook teams and, guide them, towards the vision of the company. So, to such startups and budding tech leaders, what is your advice moving forward about the future of these computing technologies? And what do you feel are the prerequisites that people need to bear in mind when they are taking charge of teams, say 10 years down the line
now? So 10 years is indeed a long time, and given the rate of pace of change, it would be quite quite risky to try and crystal gaze into so many years ahead, right? I mean, the world's quite dramatically a different place from what it was, let's say, 2 years ago now. But having said that, I think there are 3 or 4 cardinal principles, right? I think we need to having the right people, there is no substitute for it, right? And not just having the right people, but having the right systems and motivation in place so that people can deliver to their potential, right? I mean, it's very important. And when we are doing these cutting edge work, typically the experience has always been that if the teams are smaller, that's okay, but we need high caliber, high performing teams, right? So I think this people are obviously the most important. The second is obviously, and of course, startups already are, but I think there is a requirement to be agile, right? I mean, some of these are evolving as we speak, and there are the adoption of new ways of doing things, new things that come into the market, etc. Trends, watching it and being close to the ground is very, very important, because some trends turn out to be fads, some trends turn out to be game changers for the future. Right. And the important thing is that, while avoiding the mistakes of going after fads, it is imperative to, to ride on the game changers as soon as possible. Right. So we may not get everything right, but it's important to continue, be agile and experiment. Right. And number 3 is to invest in the right areas at the right time. And that is important because, so for example, Deloitte in our AI computing lab, we have what we call a supercomputing technology that we have created access to. And that is important because, there are certain areas where some of those things are required, right? So it is important for leaders to place their bets in the right direction. Lastly, but not the least, right? It's important to, while we are doing some of these innovations because they are, shiny new toys in the market, as we already spoke about, but also needs to have a real world impact, right? So eventually it has to, for companies, save cost or help increase their overall, let's say, revenues, or deepen the relationship with the customers, or may create efficiencies in supply chain, create efficiencies in production, improve their employee engagement. So there has to be a real world impact of using these technologies. And that linkage is very critical for driving adoption and acceptance within business. So I would say those are some of the critical things that leaders now and into the future need to focus on.
on the top of your mind, Prashant, what is the next big real world, innovation that quantum computing, might make it happen? Like on the top of your mind, what's the first thing you can think of?
No. The first thing I think of is, having these devices, so which are not, like wearables in some sense, right? So the power of wearables. So if I wear a specs that will do everything for me, if I have watches and all of these which don't need to be linked to mobile phones, right? I think that's one. And the second thing, especially in places like India, which we have not seen, is autonomous driving. I think that will be a real game changer if we can, I don't know if given Indian rules and road conditions, if that's going to work out, but I think it's something that we can look forward to, and it will be game changing.
You rightly pointed out some great points. Like, technology is always evolving, and leaders have to be agile to distinguish what is a fad and what is not, and keep experimenting, even though things might not go right all the time. And to be quick in investing in the right technology at the right time is very crucial for anybody in the tech field, no matter if it's quantum computing or AI/ML or any other technology that is coming up right now. So thank you so much, Prashant, for joining us for this really insightful session. I'm sure our listeners got a lot of takeaways from this podcast about the future of quantum computing technology and all its diverse applications, and the potential it holds to change the way technology is working right now, and the critical problems that it can solve in, as you said, like milliseconds and like super quick. So thank you so much for all your insight, and I'm sure even our listeners and I am looking forward to what Deloitte has to bring to the table when it comes to innovations in this spectrum.
Thank you so much, and wishing all the best.